All right, 2.5 Algebra 1, page 96 in the book. And on page 96 we have what is called the distributive property. So this is a pretty cool little thing. We'll talk about some vocabulary and then we'll get through. It's a little different than, maybe a little different than what you've done, but it's a shortcut to help you, especially in algebra when we have some unknown numbers, which are our variables. So let's go through equivalent expressions. Equivalent expressions is on page 96. It says two expressions that have the same value are called equivalent expressions. So basically those are fractions that have the same, or excuse me, fractions, expressions that have the same value. Hence the word equivalent, equal. Okay. The distributive property is a property that can be used to find the product of a sum or difference, and we'll leave it at that for right now until we get going. Okay. And then we have a term, and I'm just looking through finding all of the things. You know, maybe a term would be best described, all of these would be best described with an example. So let me write an example here. Okay, negative x plus 2x plus 8. Okay, first off, the terms are what makes up this problem. This problem, and they're separated by your addition signs and subtraction signs. This problem has 3 terms. There's the first term, the second, and the third. So we would say the terms are negative x, 2x, and 8. Basically, it's what makes up the problem. Okay? Coefficient is the variable part, the term, it's the variable part, the number with the letter. Sorry, that came out funny. The number with the letter. So negative x has an unwritten 1. There's really a 1 right there. And then 2x. So the coefficients would be 2 and negative 1. Coefficients are the numbers with the letters. Okay, so we have the terms are all the things in the problem. The coefficients are the numbers with the letters. Okay, a constant term. A constant term is a term that is just by itself. It doesn't have any letter with it. It's one of the terms just by itself. So in this case, the constant term would be 8. Okay, so a constant term has a number. Okay, and no letter. Okay, so 2x would not be, the 2 would not be a constant term because it has an x with it. 8 is constant. Okay, and like terms are the things that have things in them that are alike. So up there on my example, negative x plus 2x plus 8, you can only add things that are alike. So x's go with x's. Constant terms go with constant terms. And we'll do more of those. So like terms are terms that have the same variables, okay, and constants. And we'll do those. You'll see as we get through. This is kind of it's a tricky lesson, but this is a fun lesson. All right, so there is a key concept box. Before we do example number 1, let's talk about our key concept. The key concept here is talking about the distributive property. So they're using A, B, and C. So what they're doing is they want to show the product of A and B plus C. Okay? So if we were taking A times B plus C, we can't do this right now because we don't know what B and C are. So we can break it down and take this number on the outside and we can multiply it. We can distribute the A into the parentheses. So we're going to distribute the A into the B, and we're going to distribute the A to the C. And we do that by multiplying, since there's when there's nothing between a letter and parentheses, it means to multiply. So A times B plus A times C. Okay? They also show it by switching around. They could do b plus c. This way it's the same thing, and you would just, you could go backwards this way. So BA plus CA, and those are the same. It's the commutative property. Now, sometimes makes more sense when we do it with numbers. So you have 3 times 4 plus 2, and you might say, Mrs. Bivens, you told us to always do what's in the parentheses first. Yes, I have, but this distributive property is another way to solve this problem and come up with the same answer. With order of operations, we would do this problem like this. We'd go 4 plus 2 is 6, and 3 times 6 is 18. Well, I want you to practice the distributive property with numbers that you know, so you're going to, instead of adding 4 plus 2, you're going to take 3 times 4, then 3 times 2. So 3 times 4 is 12, plus, this sign stays the same, plus 3 times 2, which is 6, and 12 plus 6 is 18. And yeah, that's not the fastest right now, but that's not what we're practicing. We're practicing an understanding of the distributive property. All right? So then also, you can do the same thing if it's a subtraction. So look at the next part. You're writing the key concept box. This would be the same thing, A times B, A times C. So it would be AB minus AC this time because of the minus over here. And a problem like here would be like 5 times 6 minus 4. You'd go 5 times 6, which is 30. 5 times 4, which is 20, and you put the minus. I just automatically do it because I know that's minus, and that answer then would be 10. I'm not as concerned with the answer as I am just seeing that you are understanding the distributive property. So go ahead and continue to finish writing the stuff in the key concept box. So use the distributive property to write an equivalent expression. Now that's not wanting a full answer, just an equivalent expression. So all you're doing is you're taking this number times this number, and this one times this one. You're distributing the 4 into the problem by using multiplication. And if we can't add 4y plus 12, because and I know we didn't talk a lot about it, we will in a second. You can't add 4y and 12 because they are not like terms. 4y has a variable on it, and 12 is a constant term. Only variables can go with variables, constants with constants. And notice they do the arrows too, and they have 4y plus 12. So now this one, I'm just going to do this backwards. We're going to go y times y. Now y times y is y squared, and it's not 2y. A lot of times kids get this mixed up. This is y squared. Y plus y is 2y. So try to keep that straight. It's a little confusing. And we put the plus, and y times 7 is 7y. And in algebra, we always write the number before the letter. Okay, see, those are n's. N times n is n squared. And we put the minus because there's a minus. And n times 9 is 9n. So n squared minus 9. That's all we can do. We can't combine. I know it looks like these are the same, but this n is squared and this n is not. So those are not like terms. We would not be able to put those together. And then we work our way backwards. 8 times 2 is 16. Minus 8 times n, which is 8n. So 16 minus 8n. And maybe, okay. This gets a little confusing. It says use the distributive property to distribute a negative number. Now, when we're distributing, we need to make sure we bring everything with this number. This is a negative 2 now. So when we multiply, which is our distribution, we need to make sure we multiply by a negative, and a lot of kids forget the negative. So now negative 2 times x is negative 2x, and then negative 2, and I know that's a plus, but that's still a positive 7. So negative 2 times positive 7, and a lot of kids will put the plus because there is a plus, but that is negative 14. So negative 2x plus negative 14 is really negative 2x minus 14. Plus a negative. And really, that's the opposite. That's like undoing the boom, boom. So you have to take out that plus a negative and write it as minus. So that's a little confusing. So watch, we'll do more examples of that as we go through. Okay, I think the key is we always want things in simplest form. I know math isn't always simple, but we want them in simplest form. So we're distributing this number right here. It's a negative 3y, so I'm going to multiply negative 3y times positive 5, which is going to be negative 15y. And there's a minus right there, so we could write the minus, but now notice it's negative 3y times, I bring the minus down, it's done. I've dealt with both of these. So they're gone. So what's negative 3y times positive y is negative 3y squared. Okay? 3, there's a 1 right there. You take 3, it just stays with it because there's no other number, and y times y is y squared, which we talked about on that other slide. And then notice simplify, so I would have minus a negative, so that would boom boom, so it's going to be negative 15y plus 3y squared. And it's a little confusing, but once again, ooh, look at all those y's. They wrote out everything that I was talking about, and there's the answer, and we got it right. Okay, so we're still distributing negative numbers. This right here has just a negative on the outside, so what we're doing is we're distributing a negative into the inside. And another way to say negative is the opposite of. So what's the opposite of 2x? Negative 2x. What's the opposite of negative 11? Even though you might say that's a minus, but if you boom boomed it, it would be negative. What's the opposite of negative 11? Positive 11. So there's your simplified. And they may do it, you know, they really, that negative out there is a negative 1. That's what we're distributing in, is a negative 1. And remember, negative 1, the property means you do the opposite. So I forget about the negative 1, I see the minus, and I just think opposite. And I think they might do it just a little bit confusing. So I think my breakdown is a little bit easier there. All right, so now let's talk about these expressions. We have, they're going to give you an expression, and you have to identify the terms, the like terms, the coefficients, and the constant terms. And the best way to do it is to just write them out. What are the terms? So here's our expression, 3x minus 4 minus 6x plus 2. So let's start with the terms. Okay, let's write out the terms. The first term is 3x. Okay, and here's, sometimes it's a very easy mistake. It's not that is not just a 4, that is a negative 4. That's a negative 6x, and then we have a 2. Then I have like terms. Which ones are alike? Which ones could we add together? Well, 3x and 6x, the negative 6x, those are like terms because they could be added because they have the same variable. Negative 4 and 2 are also like terms because they're constants. They don't have letters attached to them. Coefficients. Coefficients are the numbers that are attached to the letters. So a 3 and a negative 6 are the coefficients. And then the constants. Ones with no, negative 4 and 2. They have no letters attached to them. So there's the terms. So I'm looking through to see if we got them all. Yes. There's the like terms. Yes. There's the coefficients. And there's the constants. It's kind of fun as long as you just don't leave out negatives. That's the worst part usually, is leaving out negatives. Okay, use the distributive property to write an equivalent expression. So we just go 2 times x, 2 times 3. 2x plus 6. And remember that you could do negative 1, or just think, what's the opposite of 4? Negative 4. And what's the opposite of minusing y? Think of it that way, adding y. Done. Easy. All right, now we're going this way. Negative 3 times m is negative 3m squared. That's a little tricky. Look at that. Really, there's a 1 right there, so I'm taking 3 times 1, negative 3, actually negative 3, and then m times m is m squared. And then negative 3 times negative 5 is positive, and I know you might not think that's negative, but it is positive 15m. There we go. half of everything. So we're distributing a half. Half of 2n is 1n, and half of 6 is 3. So n plus 3. Well, that made that look a lot more friendly, didn't it, after we got rid of that fraction. Identify the terms, like terms, coefficients, constant terms. So terms are negative 7y, positive 8, negative 6y, negative 13. Like terms, which ones have like variables? Negative 7y and negative 6y are alike. 8 and negative 13 are alike. Coefficients are the numbers with the letters, so that would be negative 7 and negative 6. Constants are the ones that don't have any letters. Whoops, I'm not spelling that right. Constants, that would be 8 and negative 13, making sure I put the negatives with it. Like terms, coefficients are good, constants are good. All right, now here's where we get to put it all together. All right, what we're going to do right here is we're going to simplify this expression as far as we can go, meaning we're going to do distributive property, and we're going to do combining like terms. So first let's do the distributive property. I hope you see that right here, just this part of it has a distributive property. You take the 4 times n and the 4 times 9. This also has distributive property. So let's do those. So 4 times n is 4n, plus 4 times 9 is 36. And then let's do this one. Negative 3 times 2 is negative 6. And negative 3 times n is negative 3n. All right? Well, what we've done is we've simplified the expression so far by using the distributive property. Now we want to simplify the expression by combining like terms. And you know what? You can do this in a lot of different ways, and I think that the book does it, the way they will solve it is a little confusing. I go through and I just look at the like terms, and I see that 4n is like 3n. They both have n's on them. So if you pretend like these are not there, it's hard, I can't cover them up. I would normally cover them up. What's 4n minus 3n's? Okay, wouldn't that be 1n? Or just n? We don't have to write the 1 when it's just one number. So those simplify to n. Now look at the numbers in the middle. 36 minus 6. That's easy. It's just 6. Excuse me, it's 30. Just 6. It's 30. So it'd be n plus 30. And the book has an explanation that will probably, let's see, it would be then B. This was a standardized test. So let's look what they did. They do the distributive property, which we agree with. But here's where it's going to be a little bit different. Oh, I thought they were going to do it out. They do it, I know, I noticed, I think they did in the book, and they did it just, oh, maybe that's example 5. I'm getting confused on, sorry. All right, so let's check out example 5, a multi-step problem. Your daily workout plan involves a total of 50 minutes of running and swimming. You burn 15 calories per minute when running, 9 calories per minute when swimming. Let R be the number of minutes that you run. Find the number of calories you burn if you run for 20 minutes. 50 minutes of running and swimming. So let R be the number of calories you run. Find the number of calories you burn if you run for 20 minutes. So we run for 20 minutes. I'm writing down what I know. 20 minutes you run, and for another 30 minutes you swim. Because we know you run for a total of 50 minutes, right? 15 calories per minute running, so 15 times 20, right? Let R be the number you run, number of minutes you run. Find the number of calories you burn if you run for 20 minutes. So let's go back. We're going to go 15 times R for the number of minutes we run. They want us to put an R in instead of 20. Okay. Plus Oh, I see what they want us to do. The swimming then would be, I don't know, this is kind of crazy to me. 9 times 20, 50 total minus R. That's confusing. I don't know. So your total minutes of running would be R, which is 20. To find the total minutes of swimming, you would take 50 minus R, which is 20. I guess that does make sense, but to me, that's just confusing. I don't know why you would do it that way. And this would come out to be 15R plus 450 minus 9R. Then you would combine the like terms. 15R minus 9R would be 6R plus 450. And then we know R is 20, and you would put it in right there. 120 plus 450 is 570. Okay, I'm going to be a rebel and do this. I would do 20 minutes of running, 20 times 15 to burn those calories. That's 2, let's see, 20 times 10 is 200, 20 times 5 is 100. That would be 300 calories. 30 minutes at 9 each would be 270, and look what I got, 570. I don't know, sometimes the algebra thing can be crazy. There's our verbal model, which we kind of did anyway. And they're just going through, coming up with the same thing that we did. So sometimes, you know, like I said, there's more than one way to do these, more than one way to do them. All right, ooh, check this out. Simplify this expression. Oh, you know what? They give us the... Okay, pretend like that's not there, because that's the answer. La, 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 la. We didn't see that. We didn't see it. We didn't see it. Okay, so there's two parts of distributive property, so I'm going to take 5 times 6, 5 times n. 5 times 6 is 30, plus 5 times n is 5n. Then I'm going to distribute in the negative 2. That's going to be negative 2n. And then negative 2 times negative 2 is positive 4. And I'm just, that negative and negative, those two make positives. So that's just a nice little... So then I'm going to add my constants, 30 and 4, and get 34. And then I'm going to subtract these because 5n minus 2n is positive 3n. So 34 plus 3n. And I think that was the answer before I scratched it out. In example 5, what if your workout lasts 45 minutes? How many calories do you burn if you run for 20 minutes? Okay, I'm going to have 15 for running and 9 for, trying to remember what they were, calories for swimming. Alright, so if I run, if it's 45 minutes and I run, I'd minus 20. Okay, so I run for 20 minutes and I swim for 25. So 15 times 20 is 300 like it was before. 9 times 25, 225. 525. That's what I say for the 20 minutes. The 30 minutes would be 30 times 15 would be 450. 15 times 3 is 45. Add the 0. And then take 30 off of 45. There'd be 15 minutes at 9 calories. 135. So 585. So 525, 585. Let's see what they came up with. 525, 585. Boom, we got it. All right. Hey, please ask. These can be really confusing, especially if you find when you're grading them you're missing a lot. Please get it straightened out with me so you can pass your quizzes and know what's going on. I'll try to come around and make sure that you're all on the right track. All right, we'll see you next time.